Hello and welcome to this video about microservice API patterns. My name is Daniel. I'm a software architect and solution architect working in many projects for the last, quite many years at least. And recently I've been given talks about the microservice API patterns, a project where I'm involved in. And I wanted to, give you an update about what's happening and what these microservice API patterns are. The slides which I'm showing here are from the JAX conference last year, with some updated numbers and figures to give you, the latest developments which we did. We shouldn't talk so long. Let's dive into microservice API patterns. Quite prominently in this name is, the abbreviation API, and I hope that everyone knows what's an API, but just a short recap. So API stands for Application Programming Interface, and that's a quite generic term. So it can be anything from a distributed service down to a local library interface. And that's quite interesting because the usage of this name has changed in the last years quite a bit. So, before it was service design, and today we call this API design. And I'm not sure why this happened. I think it's because, we have microservices and we have microservice design, which is concerned with, how large a microservice should be, how many microservices I should have, and so on. And this term has, essentially pushed service design away. And instead, we use API design now for all these remote APIs as well. So it depends a little bit on the context. Within this presentation, within this video, this for me means a remote service interface. And from a software architecture point of view, an interface is something quite interesting. So it's the best tool which we have to structure a system. And it has two sides to it, and that's quite interesting. So if you look at the English term interface, it means more like putting something together. So you have a component A, component B, you have service A, you have service B, and you want them to talk to each other. So you have an interface, which they both know. So the English connotation in interface is more putting something together, plugging something into the wall interface, for example. In German, which is, because I'm German, which is, my native language, it means Schnittstelle, or a cutting place. So that's why the scissors are there. So it means to cut something, or the place where something is cut apart. And these are two things, so cutting and fitting back together. And that's what we do in software architecture. It's divide and conquer. We break a system down into several components, and then we make sure that these components can work together in order to reach the goal which we have in our software. And interfaces are essentially really the most important means, I think, which we can use to structure our system. This also allows for separation of concerns, so I can cut around my concerns and isolate them in some parts of the software. And these interfaces are important within locally our software, our monolith, our microservice. But if we look at a service landscape having many different services, it's even more important to have clean and understandable interfaces between those systems, because they decouple not only the functionality of a system, but they also decouple the life cycle. So, for instance, I want to deploy one software, and other systems are dependent on that, and this deployment of a single software system shouldn't break all these other systems. And we can achieve that by keeping the API stable, or at least compatible. And this problem is something which is very present in microservices, because we have many distributed systems which are quite small, depending on your definition of small, but we have many systems which need to talk to each other. And we want to have team independence, which means we want to have lifecycle independence. So that's why APIs are very important in microservice architectures, but also in other places. And perhaps interestingly, even if these are called microservice API patterns, you will find quite a lot of things which you probably want to use for other APIs as well. But they are very relevant in the microservice environment. APIs have become a very critical success factor. So we want to offer services which are integrated by others. So all the software as a service offerings which we see offering APIs so that we can integrate with these systems. Or like Salesforce, where I can integrate with the whole CRM suite. And we have internal systems that we have much custom development going on, but we also want to combine these things to have a working business process across multiple systems. And when we talk about business processes, that means digital transformation. So we want to have a digital business, we want to have end-to-end support, software support of our business processes, in the best case end-to-end automation of these processes. And that means we want to have APIs to make these systems talk to each other, to have the whole business process flowing through these systems. And the better an API is, the better I can do integration and development against this API. So good APIs are easy to use, are easy to maintain, and are essentially cost efficient from a development and maintenance point of view. So why patterns? That's quite interesting. Here, the book in the background there is very old, and there has been much critique for it. And I think it's one of the most successful books of all times which we have in computer science and software and programming, at least. And why? Because no one will buy this book probably today. So why is it successful if you don't want to buy this? Well, this book defined patterns which are now everywhere in our programming languages, which everyone understands, which have created a language like iterator, like singleton, like observer, adapter. All these things have been defined in this book, and we use them and these terms on a regular basis. And well, the criticism essentially was, well, you shouldn't always use design patterns, and that's right, and that's definitely the case. And the authors and no pattern author will tell you that you should use these patterns all the time, or a certain pattern all the time. Why? Because a pattern not only has a name and a solution sketch, but it will talk about when to use it and what things you get and what things you lose in return. So software architecture is always about getting something and losing something. It's about compromising different quality attributes of your software system. And patterns really describe this. So if you're looking a bit more in depth into these pattern books, and this book, for example, and others, you will see a section called forces, consequences, or benefits and liabilities. And these are the interesting sections in the book, not the solution sketch. But what do I get? What do I lose? What's the cost for achieving a certain quality? And so that's essentially a good pattern which tells you, okay, you can do this, and under these circumstances, if you have these goals, it's probably a good idea to do this, but you will lose on the other side on these and these points, and if you want to have these points, then you probably shouldn't use this pattern. Patterns aren't authored by the authors, but instead the authors collect from known uses. So the authors are more librarians or something like that. So not the authors, not the inventors of a pattern, but people who try to find certain patterns, giving them good names, or looking for names which others have given them, looking for good examples, finding other forces, and so on. And that's, well, essentially the good part about patterns is it's encapsulated, captured experience from many, many people. And if you want to learn a domain, one way is to look at, are there pattern books or pattern languages for this domain to how to know the quality attributes, the decisions to be made, and so on. And then there's the implementation of a pattern, right? And that's the least important point. If we look at microservices, there are lots of pattern books which at least touch on some areas of these. Probably the oldest and the most important one is Enterprise Integration Patterns. And that's a book which really deals about integration of software systems. We have service design patterns, we have cloud computing patterns. All those are, well, at least touching on microservice problems. So why a microservice API patterns language? What we did is we looked for things which are concerned with the API design, the contents of the API design, and what people do, what we have seen in our projects, what we've seen in other people's projects. So these patterns are not invented by us, but they are created by us. And by us, I'll show you the team one of the next slides. And these patterns are concerned with API-related concepts and on a conceptual level. And I think that's an important point. So there are many good books about how to do a reasonably good RESTful API or how to use HTTP. You will find documentation on how to use gRPC or MQ. And back in the day, you had good documentation about Corba, about SOAP, whatever. But the Corba and SOAP books are more or less gone, and the REST books, well, okay, they will probably go as well, and the title will be replaced by HTTP something. And we will see what GraphQL and gRPC or message queues and whatever we'll get to. But the point is these technologies will vanish over time. What's interesting is that the concepts are the same. So I quite clearly remember when I was in one of my first commercial projects. So the first one I did after my PhD, and there was a large bank, and they had this huge Corba infrastructure, and they had quite interesting ways of designing their Corba interfaces, and that was something which you didn't find in a textbook. Essentially, it was contrary to things which are in the relevant standard or how the standard authors thought about things, but they worked. And some of these things are in these patterns, interestingly. But Corba is dead, but these concepts are still alive and are very useful. So we decided the Microservice API patterns will be about concepts. So if you want to understand REST or HTTP or any other technology, that's not MAP. But if you want to know how you structure conceptually an API and make it a good API, then MAP is something for you. At the moment we have 46 patterns in 5 categories, and you find this on microserviceapipatterns.org. So it's freely available, the information, and we'll dive a little bit into what's in there. If you open the website, you will find this nice little figure, and it's a map of map. So it's a map of all the patterns which we have, and we have a foundation category. We'll see later on what's in there. We have responsibility, pattern, structure, quality, and down there evolution. And I think there are quite some interesting things in there, and very often on my projects I needed to tell developers or newbie API designers, well, please do something like that, or we want to do something like that. And that's getting much easier if you can say, okay, these patterns I think are applicable because ABC. Please have a look there and go and learn these things. MAP started in 2016. So started by doing project retrospectives, pattern mining, for example, in GitHub, and looking at many APIs. So finding out what people do, what we have done, So what are good APIs? What are nice ideas in API design? So that's a while back, 5 years back, nearly 6. In 2017, we built the structure category. So all patterns which you find in structure were done in 2017. Next one was the quality category. So you see, every year there was a new category. In 2019 it was evolution, in 2020 responsibility. Now in 2021 we are a little bit of, well, tying strings together, so all loose ends, and we're working on, well, some additional material. So there's no new category this year, but there will be quite some content which we will release next year, which we have worked on this year. And that's the team. And I don't know how to position myself, so I don't overlap with anyone. But we'll just go from left to right. So the initiator is Olaf Zimmermann. So that's the correct German translation, or pronunciation, sorry. So his idea was to really collect these API related things. And he asked Mirko Stocker and me and Uwe Zun and Cesare Pautasso whether we would join this over the years. And we did, and we are now a 5-people team who, well, quite successfully works on these patterns. But for me it's really important to say it's not my work. Part of that is my work, but the credit goes to the team and to Olaf for initiating this. We will shortly go through one of my projects I'm working in, and that's TerraVis. It's a great and interesting project. It's a large-scale process integration platform. What does this mean? It means TerraVis is a system which connects land registries, notaries, banks, and lots of other parties across whole Switzerland with the idea to fully conduct business processes in a digital manner. So really end-to-end processes. Or processing of land registry businesses, including digital signatures, structured data, and many systems in our environment. So there are over hundreds of land registries in Switzerland. There are hundreds of notaries. Switzerland has many banks. We have a trustee. We have surveyors. We have interbank clearing, and we have lots of things and partners who are in our environment who want to use TerraVis in order to interact with land registries or land register related, especially mortgage businesses. And so you see in our environment there are really thousands of systems. So I think it's around 2,000 different partner systems which we have in our environment. So that's quite a lot, and that is one of the technical challenges. And if we look at TerraVis, we have our partners like banks, notaries, and we have different modules which we offer in TerraVis. And you see we have query. Query is essentially, we'll talk about what it is technically, but functional wise, it allows a bank or notary to access land register data in a unified manner. So regardless of where a parcel is located in Switzerland and which land registry is responsible, this will all be hidden by query in order to have a unified view. So to note here, so Switzerland is a federation, and every canton, so like a state in the US, is responsible for the land registry. So there is no Swiss-wide land registry or land register database. These are all local to the cantons, and sometimes the cantons even delegate this down to a city or village. We have the nominee module, which essentially where mortgages are managed for banks. History is quite interesting, but from a technical point of view, it's a very easy system. It's just stored, and this mortgage belongs to a certain partner. And we have this big blue box, the process automation. So there's most of the complexity of the business is hidden in that. And there we have different processes. We have document generation facilities. We have business rules. And you now see in the upper right in the Terravis portal. So why is there a portal? Well, the idea initially was that every partner will integrate via APIs to Terravis. And for a number of reasons that didn't work out. So we offer APIs, but we also offer a web portal where a bank or notary, etc., can conduct the same businesses as they can do via their system if they have an integration. If we look at the types of API, and you see that here on this side here, so we have community APIs and solution internal APIs. So these are the first patterns, and these are quite easy patterns because it's more like a flag. So who's my client audience? And we have, for instance, APIs between banks and query. So banks can search for parcels in Switzerland. Banks can access the nominee functionality if their mortgages are managed by a trustee. And of course we have all kinds of partners who will interact with the processes. So these are all community APIs. And then we have, we also have a community API between the portal and the process. So the portal has no home advantage at all. It just uses the same APIs as the partners do. It's a kind of reference implementation for us. That's the benefit, although we initially didn't want it to do that. But it's a reference implementation, and it uses really the same APIs to our backend. It's like a small banking or notary system. And it's not an integrated part of our solution. It's a front end. It's a pure front end application. And then we have solution internal APIs. So the processes may call the document generation facilities to get documents, and they call business rules to validate certain things. So we have different APIs, and we have different control over these APIs. And that's the important point here. So if we look at what we can change between a bank and us, it means we need to consider that the bank perhaps needs to change as well. While internally, if we change the process and the document generation, we can deploy this together and we are ready to go. And so there are differences in what we can do and to whom we need to talk to. So that's important to make you aware of what kind of API you have here. And there is also another option which we don't have in Terravis, but which would be a public API, which you just offer to anyone. I've talked a little bit about our interdependencies with these partners, and for instance, banks are not the most agile organizations, and they have certain deployment frequencies which are usually not within the range of a matter of weeks, but more measured in months. So we need to have a stable API. How do we achieve that? So first of all, we have a tune production pattern, and that's what we use at Terravis. So tune production means we have an old version and we have the newest version, and if a bank uses the old version and now knows, okay, I need to plan to move to the newest version, because if there's a next version, there are 3 in production in parallel, but the oldest one will get removed. And I think that's very important. People are quite eager, or many textbooks are quite eager to show you how you push new services, how you create new services quickly. But from a maintenance point of view, if you want to maintain your platform over the years, you also need to have a way to get services away from your platform, to put them down, to remove them. And these evolution patterns give some ideas on how you can do that. So tune production is what we use at Terravis. we also have an explicit identifier, and just so that you know, it's not really that agile it's not that we push new incompatible versions all the time, because people imply, or very often in discussions say, okay, well, you're bad, you're using version identifiers. Well, don't necessarily. And it's not that I tell my customers, oh, well, you need to upgrade all the time. So we have 3 banking versions across, or since I think about 12 years time. So one is retired, only one is retired. So in the worst case, as a bank, you need to have 1 migration in the last 12 years. And that's not a lot of change, so we make sure that these versions and changes to these versions are compatible as much as possible. But at some point there are changes in the legal framework which require us to change things. And so then we are not compatible anymore, and then banks need to move to a new version. And on the land register side, we had 2 versions in these 12 years. So we support every version released in these last 12 years. So it's not that necessarily by saying, okay, we have a version identifier and we have some kind of strategy how to phase out versions, that you just tell your customer, oh, you're now getting, well, all night and day in the next 12 years to work on migration to the newest API versions. That's not the case. To the contrary, we have made good experiences with declaring which version is something, and especially when pushing around documentation and BAs analyzing our processes and our APIs, it's good to reference versions. And we use the semantic versioning scheme, so these 3 part version number, major, minor, fix. And this indicates compatibility between these versions, and most of our changes are really fixed version changes where we add small things but remain completely compatible. And then we have minor changes where at least we can easily migrate to this version. And then we have we don't have any major version. I think that's the point. Over the last 12 years, we don't have really a complete revamp of our APIs and say, okay, we throw everything away. That's why Terravis is quite stable, although it uses these patterns which at least guarantee for both sides that they can plan on how to proceed and what to expect in terms of migration and maintenance and integration efforts. Another important part is security and context propagation. So there are certain metadata in every message which we send or which we receive in every service call. So we know which partner is it, we know whether this partner comes from a portal or comes from an external system. And this allows us to also say, okay, Bank A has integrated, let's say, increased mortgage business, and that's a very complicated process with many options. And perhaps this bank has integrated, like 10%. So the standard cases work. But whenever they want to use more advanced functionality, they can still use the portal. That's why in every message we say, okay, this is from this and this bank, this land registry, and it's coming from their external system or via the portal. We have the user ID, we have a message ID, and we have a business process ID. So that's the minimum of all context information which we have in messages going or are being used in this business process automation part. And this allows for many things. So since if we see a dump of a message, we know which process it belongs to. It's easy to correlate messages to business process instances. It's easy to analyze log files even across different services, because we all have this metadata which allows us to correlate logs and messages and all this stuff. And context representation is a pattern in map, and in map there's a bit more detail in the description. So we have a message context and we have a global context. So for instance, the message ID belongs to the message context. So for every message it will be different ID. But the business process ID is the global context that spans across different messages. So there's an exchange, a conversation with different service calls, and these are grouped by this business process ID. Another important part is how to report back errors, and these in the best case are really machine readable errors, and there's a pattern called error report, and that seems to be an easy task. If you look at many APIs, it seems that, well, okay, we just give you 500 HTTP 500 error if this and this happens, and then you say, okay, well, but why did it happen? So what failed exactly? And in our case, well, okay, there are banks in the French-speaking part of Switzerland, the German-speaking part, and the Italian-speaking part. So who translates all these errors? And well, Terravis doesn't. Terravis will return error code, and every system can understand this code and can give a translated error or can react accordingly. We also have a list of error objects. So let's say you want to work on a mortgage type which isn't allowed in this context. We'll tell you, okay, the error code is mortgage type not allowed, and we tell you, out of these mortgages which you passed me, mortgage 1, 2, 3 with this ID fails this test. There's an English fallback error message, so that if you look at on the wire messages, or even if the system doesn't understand the error code for whatever reason, you have at least some description. You get a related message ID, so you know to which request message this belongs to, and you get a business process ID, so you know to which business process this belongs to. So you have a set of metadata here describing errors, and that's described or it's applied according to the error report pattern. If we look at the portal, there are tasks certainly. So people can't work with API calls, they work with tasks. So one of the main functionality of the portal is to translate API calls to some human tasks. And now people, or you look at, we need to, for auditing reasons, we need to keep 10 years of history. So a bank over 10 years has lots of land registry businesses and has lots of tasks in these businesses and these business processes. So, well, how do I present these tasks to the banks? And well, it's done by using pagination. Pagination is a pattern which describes different strategies to chunk a large response into smaller chunks. And on the UI level, we see this quite frequently. So if you open the Google search, you get, I think, 20 search results. Then you can click next and you see, well, how many pages you have. You have a total number of things. And here it's not search results, but it's tasks. So you get the first 20 tasks, you can move to the next page, go back to the next page. So from a UI perspective, that's quite easily described and users expect this. This pattern can also be used for backend integration, so you just don't copy a whole data set, but you chunk this in order to have more reasonable sizes to work with. What many people developing backends don't know is that there are quite a lot of strategies to how to implement this pattern, and not only from the database access, and there are many errors done, implementation mistakes done on this side, but also in what you offer your API client on options. So you can have cursor-based navigation, you can have page-based navigation, for instance. And these are very different, and these are all described in this pagination pattern. In Terravis, it's quite easy. So it's a page-based navigation. So you get your task. You have some search criteria like task name and process type, and you say, okay, I want to go from a certain index and with a certain page size. So deliver like 20 tasks starting from task 100 to me, and the response is then structured accordingly. So you get back these 20 tasks which you requested, you get back a total amount of tasks, and then the UI can be rendered in a meaningful way to the user. On the process side, we have many different service calls, many different operations which we offer, but they follow a certain schema. So we have a pattern called state creation operation. So you now might wonder why is this a pattern, but there are many things which you can deduct from knowing that you have a state creation operation to make better informed design and architectural decisions. And in Terravis it's quite easily marked. If something is labeled start XYZ, then well, it's a state creation operation. You create a new business process instance. And if it's not called start, then you don't. If you do activities in this process, then you have state transition operations, again a pattern from the Microservice API pattern library. And there are certain naming conventions which are a bit more complex, so and I don't think it's helpful here, but they have different names. And then we have events. One is, for instance, notify nominee depot update. So there was a change to a depot, and the event data will carry what things have been changed. And there's a difference between state transition operations and notifications. So in state transition operations, you initiate an action, and you somehow get a response back in the way that you have a new state. So for instance, Terravis may ask a bank, please validate me this request. And the bank can then say confirm or reject. And so I accept this or I don't accept that. But with a notification, there's no response. So we just push our messages in either direction to say, okay, here something has happened. And all these operations are called notify when mapped to, in this case, these are SOAP XML messages. But certain guarantees are made clear by the name, which in turn refers to a certain pattern which describes a set of constraints which you have for your operations. We have, and we've seen this in the overview, document generation services. These are computation functions. What's a computation function? It's not a state creation operation, for instance, but it's something which is kind of like a stateless function. So you pass data in and you get something back. There is no state change. These are all idempotent calls, which have some advantages and some disadvantages. But here for document generation, it's a very natural choice. Although you probably don't say I compute a document, but I generate a document. But this pattern will describe the constraints for these type of operations. And that's my favorite pattern here. So I'm a bit overlapping the text, so I move a bit to the side. When I talked about, well, things which looked strange in my first project in this bank, then that was this pattern. And why? And what's this pattern? So pattern is called bulk mortgage, not pattern, the service here is a bulk mortgage transfer. And the pattern which is used is the request bundle. And the request bundle essentially puts a number of requests into one operation, into one call to a service. Instead of having many small calls or large calls, doesn't matter. Instead of having many calls, you have one call which contain all calls. So essentially you have a request message which contains 20 requests. In this case, you can initiate like thousands of transfers in your trusty position keeping. And an interesting thing is a request bundle doesn't span a whole transaction, so each request can fail or succeed on its own. And that doesn't work too well with the standard transport error codes. So you cannot just say, okay, I've got an HTTP 500 or 44 or whatever for my request, for my response to a certain request, but I need to put this into the payload because I have many requests, and for each request I need to return a sensible answer. And so this doesn't really map to it doesn't map well to the technologies like they're in the textbook, but you need to keep certain or put certain things which you would otherwise keep on the protocol level, putting this down into the payload. And it looks like that. So here you have a transfer of at least one asset, but it's a list. You say which asset from which depot to which depot, and in the answer you have a transfer result. And you see, okay, an asset which was in my request and it was processed in the status okay or not found or not allowed or something like that. There's also another interesting pattern for managing, processing resources and also network bandwidth, which is the wishlist pattern. And the wishlist pattern essentially says, okay, when I make a call, in this case it's a get password by ID call, so Terabis to the land registry or bank to Terabis can say, I want this certain set of data for a parcel. So I want everything, I want full history, I only want certain information. And depending on what wish I have, I put this in my request, and I put a certain burden or relieve my provider of that burden to gather all the data or a certain amount. And when I serialize this to JSON or XML or whatever I use, then my payload is smaller if I requested not so much data. And we've seen this in the last years as an uprising pattern, quite interestingly. So here in Terabis we say, okay, we have an ID which is called the parcel ID, in German the abbreviation is egret, and then we have a query type and the flag include history. So we have bundles of or sets of attributes which we can fetch. So it's not like that you can say and specify on an attribute level, like in GraphQL, what I want to have returned, but it's a set of predefined response types. That was only a short overview about patterns which have been used in this project to just give you an idea. There are other ones like the conditional request, which only returns the full responsive data exchange. We have API keys, so where we can do system authentication based on a shared secret. We have other life cycle and evolution patterns like aggressive obsolescence, where we try to synchronize life cycles of applications by having finer, on a finer granularity level, removing features if necessary, or eternal lifetime guarantee, which some people propose, but which I think is completely irrational and unrealistic, so to guarantee that an API lives forever in a comfortable manner. But it's a pattern which is also on our homepage. So, and here is again an overview of all the patterns which we have described so far. And if you found this interesting, which I hope you do, then you find all these patterns free to use on our website. Our goal is to really provide a resource of these patterns to come to shared language. So If I say pagination, if I say request bundle, if I say tool production, that everyone knows what I'm talking about. That would make life much easier for every API designer. And also as a help for, well, not only for beginners, so I also go and browse through these patterns when I do a new API and look at, well, what decision do I need to take? What have I missed? And also in the patterns, there are implementation hints, so you can have a look at what people do or recommend when applying this pattern. You can use this for free. It's a microservice-api-patterns.org. So happily use this content, comment on it, and if you have any questions, drop me an email or a message. And if you like this video, please like it down below, thumbs up, and subscribe to this channel. Thank you, and see you in a later video.